Hello everyone, welcome to my YouTube channel. Many of you have requested me to make a video on bypass. Okay, so in my today's class, I shall discuss bypass and some important application of bypass that will be helpful for students for NEP mathematics syllabus, both honors and general students. Okay, so before discussing a very important chapter on bypass, at first I shall explain bypass method. All of you know bypass method, but still take a division on bypass at first. So what is bypass method? Bypass method is, suppose we are given to function of x, u is equal to some f of x and v equal to some another function of x, gx. Say u and v are two different functions of x. Say u equal to my fx and v equal to my gx. Then the question is how we can find integration u into v. This is called bypass method. Okay, so bypass method says you have to integrate u into v. So how to integrate u dot v? This is called bypass method. So bypass method says integration u dot v dx. That will be, say u is my first function and v is my second function. I shall explain you how to choose the first function and second function. Say u is my first function and v is my second function. Later, I shall explain how to choose this first function and second function. So the thing is integration u into v dx. If we take u as first function, v as second function, the integration will be first function into integration of second, first function into integration of second, minus integration ddx of first function, ddx of first function, then integration of second function dx. This is called bypass method. Okay, write down this formula. Just pause the video and write down the formula. First function into integration of second minus integration derivative of first function, then integration of second function, then this dx comes for this integral. For this integral, this dx occurred. Okay, so this is called rule of bypass. And if there is a limit a to b, suppose there is a limit a to b, this is called definite integration. If there is a limit, say a to b, then we can write this bypass method as u into integration v dx over the entire part. We shall consider the limit a to b. For this entire part, we shall consider the limit a to b. Okay, not only over this integration. Okay, for this entire part, we shall consider this limit a to b. Some students make a mistake. They put the limit only over this part. But that is wrong. You have to take the limit over this entire part, u into integration v dv, not only on integration v dx. Okay, right? Then minus integration, put the limit on this integral only. Put this limit on this integral only. Then ddx of first function, then integration v dx, then dx. Note that don't put the limit over this integration because the limit is already taken over this. Obviously, and there's a third bracket. This limit is already taken over this entire integration. So you don't need to consider limit for this integration. This is called rule of bypass when there is limit. Okay, so this is called basic bypass method. And to choose u and v, there is a method. This method is called ILATE method. ILATE. By this method, we can choose the first function and second function. For example, here a is what? Say, if we take all the things here my I is called what? My I is inverse function. Say tan inverse x, cot inverse x, sin inverse x. My L is what? my L is log function, my A is algebraic function, my T is trigonometric function, and my E is exponential function. In this order, we can select the functions by ILATE rule. I for inverse function, say sine inverse, cos inverse, L for log function, A for algebraic function. Algebraic function, for example, say x square, say 2x plus 1. These are my algebraic function. T for trigonometric function, and E for exponential function. Exponential function like, say, e to the power minus x, e to the power 2x, like this. Okay, so by this rule, we can choose the functions by ILATE rule. And always remember, we always integrate over second function. We always integrate over second function, not over the first function. By this rule, you can easily choose my first function and second function. There is my first, see that there is I and L. Suppose we have inverse function and log function. In that case, my I will be first function, my log will be second function. If we have log function and algebraic function, we shall take L as log function, first function, algebraic as second function. So in this order, first function and second functions are selected. Right? Okay. So just pause the video and you can write down all of this. So this is the method of choosing first and second function. Now take an example on it. Okay, just take an example on it. So look at this example of ILATE rule. Here we have to solve this integration, integration x into e to the power minus x. This is a basic integration. Integration 0 to infinity x into e to the power minus x. So what is my rule? According to my rule, my x is called algebraic function. Okay. And my e to the power minus x is exponential function. Okay. And by ILATE rule, A comes first and E comes second. See that. Okay. So my algebraic function, x is my algebraic function, and my E is stand for exponential function. Okay. So rule of bypass says what? We shall take this one as first function and this one as second function. This is my rule of bypass. So the rule is first function, that is my first function, then integration of second function, that means integration e to the power minus x. And all of we know that integration e to the power minus x is minus e to the power minus x. It's very easy. It's very easy. Integration e to the power minus x dx equal to simply minus of e to the power minus x dx. The first function into integration of second function, integration of e to the power minus x is minus e to the power minus x. And according to our rule, take the limit over entire part, not only over this. Take the limit on this entire part. Minus, according to my formula, look at the formula. The formula is integration ddx of first function. So here, this will be integration ddx of first function, then integration of second function. This is my integration of second function, then dx, then dx by this rule. Okay. Now this thing is over. Now we know that at first you need to put upper limit, then lower limit. We know this theory. At first you need to put upper limit and lower limit. So see that if we put the upper limit on e to the power minus x, this will be e to the power minus infinity. See that. At first we shall put upper limit. See, if we put infinity on e to the power minus x, that will be e to the power minus infinity. And we know e to the power minus infinity is 0. That is the result. E to the power minus infinity is 0. Upper limit minus lower limit. My lower limit is 0. Put x equal to 0. This becomes 0. My lower limit is 0. So we shall put x equal to 0. So my lower limit is also 0. So my upper limit is 0. My lower limit is also 0. So 0 minus 0. And for this part, my ddx of x is 1. And this portion remain as it is. Finally, this portion vanish because 0 minus 0 is 0. We are left to it only this portion. We are left with only this portion. Minus minus plus integration 0 to infinity e to the power minus x. Then integration e to the power minus x, that will be minus e to the power minus x over the limit 0 to infinity. Again, the same thing, put x, put upper limit here, that will be e to the power minus infinity. Then put lower limit here, means x equal to 0. So this will be e to the power 0. Okay. And finally, e to the power minus infinity is 0. And something to the power 0 is always 1. So my e to the power 0 become 1. My e to the power 0 become 1. And finally, the answer become plus. So just pause the video and write down everything. And if you find any difficulty to understand the concept, you can ask me in my channel. Okay. In comment box, okay, you can tell me about your doubt. Okay, so this is my 5 parts method. It's a very basic thing. We have done all this thing in our HS course, just a basic revision on 5 parts. Now we are going to discuss some important application of 5 parts method that is very, very helpful for our NEP syllabus. This is a basic example of 5 parts method. Now we shall discuss it in detail, and we shall apply it to solve a very important chapter. Okay. The chapter name is successive simple chip reduction. Reduction. It's a very important chapter under integral calculus. Reduction. This reduction is basically a core application of 5 parts. Okay, here you have to understand everything on 5 parts method. So we are going to discuss some important few example of 5 parts method. So this chapter is called reduction. In this chapter, at first, we are going to discuss an important reduction. This is called reduction for integration sine to the power nx and integration 0 to pi by 2 sine to the power nx. Okay, we are going to discuss a very, very important reduction. This is called reduction for integration sine to the power nx and integration 0 to pi by 2 sine to the power nx dx. Okay, so it's an important application. So how to solve this type of integration? At first, we shall solve this integration. Okay, let this integration be denoted by this notation in. Let in equal to integration sine to the power nx dx. This is a simple notation. Okay, don't get confused with this notation. It's simply a notation. You can change it according to your convenience. But this is a standard notation. Okay, in equal to integration sine to the power nx dx. Now, how you can simplify integration sine to the power nx dx? Say that. Now, there is an application of 5 parts. At first, write down this integration like this: sine to the power n minus 1x into sine x. Obviously, we can write this by laws of indices. Sine to the power nx can be written like this: sine to the power n minus 1x, then sine x dx. Now, we shall apply 5 parts method. How to apply 5 parts method here? Let us take this one as first function and this one as second function. Okay, to solve this integration quite easily, we are taking this portion as my first function and this portion as my second function. Okay, why? So that we can easily solve it by 5 parts method. That is why we are taking those. Okay, so we are taking this one as first function, this one as second function. So what is the rule? The rule is, we know the rule: first function into integration over second. There is a rule. We know this rule of bypass. Okay, first function into integration of second minus integration ddx of first function, then integration over second function, and there is another dx for this integration. Sorry. For this integration, there is another dx for this integration. Okay, right? So this is my application of bypass. Okay, you can see this formula here. First function into integration, just write down this formula. Okay, we have applied this formula for this integration. Then what? This portion will remain as it is. Now there is a formula, integration of sin x. Its formula is minus of cos x. This is a very basic formula. You can find this formula from any book. Okay? Okay, you can go to any book for this formula. Integration sin x equal to minus cos x. Minus integration. What is ddx of this? Derivative. Chain rule differentiation, recall. Derivative of x to the power n. This is n into x to the power n minus 1. Ddx of x to the power n. There is n into x to the power n minus 1. So how we can differentiate this? At first, take n minus 1 here, n minus 1. Then sine to the power n minus 2x. Okay, the thing is, power get reduced by 1. Here it is n minus 1, here it becomes n minus 2. So ddx of this, n minus 1, then sine to the power n minus 2x, then derivative of sine x. Derivative of sine x is cos x. Chain rule differentiation, this n minus 1 comes here, then sine to the power n minus 2x. Then chain rule differentiation says you have to differentiate sine x again, and derivative of sine x is cos x. And integration of sine x is minus cos x. Right? So this become my bypass. This become my bypass. This, okay, right? Then what? This portion is minus cos x sine to the power n minus 1x. If this portion remain as it is. This portion remain as it is. Then minus minus plus, you can take n minus 1 outside this integration. Because n minus 1 is a constant. Then under integration, we are left with sine to the power n minus 2x into cos square x dx. Simple. Sine to the power n minus 2x cos x into cos x giving you cos square x. Finally, minus cos x into sine to the power n minus 1x plus n minus 1 Now see that this portion remain as it is. Cos square x. How we can write cos square x? There's a very basic formula. Cos square x can be written as 1 minus sine square x dx. See that. Cos square x can be written as 1 minus sine square x. So my IN become what? We are writing cos square x as 1 minus sine square x. Then what? First portion always remain as it is. First portion always remain as it is. Plus n minus 1. See that for this portion, simple multiply. Multiply this with 1. Multiply this with 1, giving you this into 1 means sine to the power n minus 2x dx. See that. Simply multiply this with 1. Then plus into minus, giving you minus, obviously. Plus sign into minus sign, giving you minus sign. N minus 1 remain as it is. Under integration, what? Under integration, see that. Under integration, we have sine to the power n minus 2x into sine square x. See that. N minus 1, sine to the power n minus 2x into 1, giving you this. Then the second thing is sine to the power n minus 2x into sine square x, Giving you what? Giving you sine to the power n minus 2x into sine square x. We know by laws of indices, you can add the power like this. You can add the power like this, n minus 2 plus 2. That's a very basic property. We can add the power minus n minus 2 plus 2. So minus 2 plus 2 gets cancelled. We are getting simply sine to the power n x. Done? We are getting sine to the power n x. And recall, this is my IN. Recall. Right? Just multiply this with sine square x. Power n minus 2 plus 2. N minus 2 plus 2 giving you simply sine to the power n x. So this becomes my reduction. Okay, right? Then what? This implies my IN equal to this portion always remain as it is. Plus of now. Now what? Can you see that? This is what? Compare this with this. Compare this with this. See that here my power is n minus 2 and here my power is n. See that if power is n, this is said to be IN. See that. If the power is n, this is said to be IN. So here my power of n is power is n minus 2. My power is n minus 2. So this portion will be simply IN minus 2. I again repeat. Here my power, just write down fairly. Here my power of sine is n minus 2. In this part, my power of sine is n minus 2. And here my power of sine is simply n. If the power is n, this is said to be IN. So here my power of n is n minus 2. So this must be IN minus 2. This must be IN minus 2. And finally, see that there is what? There is simply my IN again. See that? There is simply my IN again. Right? So see that we are getting this. This is my I n minus 2 because my power is n minus 2. And here the power is n. Compare this. If this is IN, this will be IN minus 2. N minus 1 remain as it is. And this is our direct IN. Okay. Right? Okay. I again repeat, if you find any problem or any difficulty, you can ask me in my YouTube channel in my comment box. Okay. I shall answer your question. And finally, see that you can take this IN to the left hand side. You can take IN to the left hand side. My right hand side remain as it is. This is the first term on right hand side, and this portion remain as it is. Now take IN common. If we take IN common, here it is 1, and here it is n minus 1. This portion remain as it is. Finally, you can see that 1 gets cancelled. N into IN. N into IN. My right hand side is as it is. My right hand side remain as it is. So from this, see that my IN become what? My IN become divide by n. My IN become minus cos x. My IN become this plus this. See that this is my final structure of IN. So we have reduced IN in this form. See that this is my structure of IN. Just pause the video and write down this entire thing. My IN becomes this. This is the first part. The second part is what? See that we have to find out integration 0 to pi by 4. sine to the power nx, right? This was, sorry, 0 to pi by, sorry, it will be 0 to pi by 2. Just correct it, it will be 0 to pi by 2. It will be 0 to pi by 2. So the second part, you need to find out integration 0 to pi by 2 sine to the power nx. Okay, so how you can find integration 0 to pi by 2? Pi by 2 is most probable question for you. Okay, so 0 to pi by 2 sine to the power nx dx. So now we shall find out this integration 0 to pi by 2 sine to the power nx dx. Let us denote this by Jn. Jn. Say, it is a standard notation. Say Jn equal to integration 0 to pi by 2 sine to the power nx dx. So, can you see that what is the difference between In and Jn? See that my In is without limit. My In is without limit, and for Jn there is a limit 0 to pi by 2. So, what is the relation between In and Jn? Can you observe? It is very easy to observe the relation between In and Jn. Answer is, the relation is Jn is equal to limit over In. Because see that if you put limit over In, you shall get Jn. Just see that if you put limit over In, if we put the limit on In, we are getting Jn. There is my Jn, right? There is my Jn. Basically, In is without limit. And Jn is with limit. With limit. There is the only difference between them. In is without limit and Jn is with limit. Just write this. In is without and Jn is with. There is my Jn. You can also observe this. There is my Jn and there is my In. There is my In. If you put limit over In, this Jn will be obtained. So just put this limit over In, we shall get Jn. That is why it is written that Jn is equal to limit over In. Because In is without limit and Jn is with limit. So putting limit over In, we shall get Jn. So my Jn is simply this, that's it. Now what is my In? My In is this entire part. There is my In. Oh. There is my In. So if we put limit over In, we are getting Jn. So if we put limit over In, we are getting Jn. Okay, any confusion? If you find any confusion, you can ask me in my channel. Okay. So my Jn become what? At first, put the limit here. Okay, so there is my Jn and this is my limit. Okay, actually I'm not habituated with this digital board, so I'm facing some problem in writing with this digital board. That is my big issue. But I think as the day progresses, I shall manage because I'm facing some problem in writing this digital board. Because I'm making my first video on this digital board. If you go to my previous videos, you can see that all the videos was in my whiteboard. But the first time I'm making video in this digital board, so I'm facing some problem in writing. So try to adjust later as the day progress. I think I can manage this problem. Okay, so this is my chain. We are putting limit over in and we are getting chain. Now, how to put the limit? We know at first put the upper limit. At first put the upper limit, then put the lower limit. We know this trick. So at first I'm going to put the upper limit. See that if we put the upper limit here, what is the value of cos pi by 2? Cos pi by 2 is 0. Upper limit minus lower limit. If we put x equal to pi by 2 here, see that there is my cos pi by 2. My cos pi by 2 is 0. And for lower limit, if we put x equal to 0 here, we know sine 0 is 0. Whatever be the power, that doesn't matter. My sine 0 is 0. So my upper limit, my lower limit, both equal to 0. Because again repeat, if we put upper limit here, cos pi by 2 is 0. If we put lower limit 0 here, my sine 0 is 0. So everything is 0. And for this part, there is my n minus 1. And so n minus 1 by n. So n minus 1 by n, you can take outside. Then you can put the limit I n minus 2. Okay, 0 to pi by 2 here. So n minus 1 by n, I n minus 2, and put the limit over 0 to pi by 2. Now, recall, if we put limit on in, we shall get jn. Okay, remember this theory and write down separately. Put the limit on in, you shall get jn. Because difference between jn and in is nothing. Simply, okay, except this limit. If you put the limit on in, you shall get jn. So it's a very important application of my parts. So what we are getting, my final answer will come jn equal to n minus 1 by n, jn minus 2. See that, it's a very, very important result. Okay, an important application on vectors. So just write down it. Later I shall give you more example like this. Okay, so this is the result. This is called reduction for sine theta. Reduction for sine theta is a very, very important result. My next reduction is integration tan to the power nx dx. This is another important application. In equal to integration tan to the power nx. Okay. This is my second application on by parts, integration tan to the power nx dx. And later we shall put the limit, but here the limit is 0 to pi by 4, tan to the power nx dx. Why not pi by 2? We shall see this later. Why not pi by 2? So at first we start with in equal to integration tan to the power nx dx. So how we can find this integration? Integration tan to the power nx. This can be written as tan to the power n minus 2x into tan square x dx, like this. Okay. Integration tan to the power nx is equal to integration tan to the power n minus 2x into tan square x. So this can be written as integration tan to the power n minus 2x and this tan square x. Now there's a theory. We know this theory from our class 10 course. Tan square x can be written as sec square x minus 1. So very basic formula. You can find this formula in any trigonometry book. Okay, my tan square theta can be written as sec square theta minus 1, like this. Tan square x equal to sec square x minus 1. This is a very important formula. And we know this formula. So, then what? You can separate this into two parts. 10 to the power n minus 2x into sec square x minus integration 10 to the power n minus 2x dx. We are separating this entire integration into two parts like this. Okay. Just separate this integration into two parts like this. Now, how we can calculate this? How we can calculate this? See that. Now, here you don't need to use by parts. Okay, though we are apply by parts method, but in this question, it is okay. If okay, but here you don't need to use by parts. In fact, it is a very easy application because for the first integration, say for the first integration, okay, so it is not an application of by parts. I shall give you another example of by parts later. But in this question, don't need to use by parts because if we take tan x equal to z, see that if we take tan x equal to z, my sec square x dx will be equal to dz. Tan x equal, simply put tan x equal to z because derivative of tan x is sec square x. So sec square x dx equal to z dz. Then what? Integration. If we put tan x equal to z, my sec square x dx means this portion become my dz. Sec square x dx, that portion become dz, and tan x equal to z. So 10 to the power n minus 2, that will be z to the power n minus 2. See that. Sec square x dx, that becomes dz, and tan x equal to z. So 10 to the power n minus 2, that will be z to the power n minus 2. Because my tan x is z, so 10 to the power n minus 2 equal to z to the power n minus 2, like this. Okay, and for the first and for this second question, see that this equal to in. What is the difference between these two? Here the power is n, but here the power is n minus 2. See that here my power is n and here my power is n minus 2. So if this is in, this must be my in minus 2, right? If this is my in, this must be my in minus 2. Okay? Done. So simple substitution method we can apply here, and if we integrate this, we know integration x to the power n, that is x to the power n plus 1 by n plus 1. X to the power n plus 1 by n plus 1. So here the formula will be this plus 1 by this plus 1. This will remain as it is. And finally, this becomes z to the power n minus 1 by n minus 1 minus in minus 2. So this is my reduction formula for 10 to the power nx. The reduction formula is put the value of z here. My z is 10x. My z is 10x. So it becomes 10x to the power n minus 1 by n minus 1 minus in minus 2. See that. What is my z? Say that my z is what? My z is 10x. So put z equal to 10x here. This will be 10x to the power n minus 1 by n minus 1. This portion remains as it is. So this is my reduction formula. Reduction formula for what? My reduction formula for tan theta. Okay, this is my reduction formula. But in CU, we get so many questions from this. Integration 0 to pi by 4 10 to the power nx. Let it be some j. Let it be some j. Say this is my Jn. Jn is integration 0 to pi by 4, 10 to the power nx. And we know, recall, if this is my in, recall the formula. If we put limit on in, we shall get Jn. We know if we put limit on in, we shall get Jn. Okay. That means my in is this. Put the limit 0 to pi by 4 on it. And think yourself, how you can solve this? Okay, think yourself, how you can solve this? Now, if we solve, see that. We can write this like 10x to the power n minus 1, pi n minus 1, over the limit 0 to pi by 4, then I n minus 2, over the limit 0 to pi by 4. Obviously, we know this thing, okay, we know this thing. At first, Jn equal to limit over In. This is my In. We have done this. This is my In. Then my Jn is what? My Jn is, at first, put x equal to pi by 4 upper limit. Put x equal to pi by 4 here. And we know that 10 pi by 4 is 1. That's a very basic thing. 10 pi by 4 is 1. So if we put x equal to pi by 4, this become 1. And 1 to the power something is 1. 1 to the power anything is 1. And if we put the lower limit, 0, we know 10, 0 is 0. So there is this portion. And for this portion, again theory, put the limit over In, you shall get Jn. Put the limit over In, you shall get Jn. So my Jn become what? 1 by n minus 1 minus Jn minus 2. See that. This is my integration reduction formula for tan to the power nx. So for next application of bypass, so it is not an application of bypass, but still it is very important. Next application of bypass is my In equal to integration sec to the power nx dx. It's again important application. In equal to integration sec to the power nx dx. So there is an application of bypass. How we can solve this question? Write down this like sec to the power n minus 2x into sec square x dx. See that. For this type of bypass, at first, we are writing sec to the power nx like sec to the power n minus 2x into sec square x. Okay? Sec to the power n minus 2x into sec square x. Then, how we can bypass? Okay, how we can use bypass to solve this? My first function is what, and my second function is what? See that we know integration of sec square x. All of you know integration of sec square x. Write down the formula. Integration sec square x is tan x. Integration sec square x is basically tan x. So we shall use this theory here. Say there is my first function, there is my second function. There is my first function, there is my second function. Because we know integration of sec square x. That is why we are taking this one as second function. So what will be the formula? See that the theory is first function into integration of second function minus integration ddx of first function into integration over second function. So is my parts? First function into integration of second minus integration ddx of first function, then integration of second function. Then what? Then sec to the power n minus 2x remain as it is. Integration sec squared x is tan x. Use this formula. It's a very basic formula. Integration sec squared x is tan x minus integration. How to differentiate this? At first, n minus 2 comes here. Then sec to the power n minus 3x. Then ddx of sec x. Basic differentiation. And ddx of sec x is sec x into tan x. I can repeat. We have to differentiate this. Rule of differentiation is what? This power comes here. Then this power reduced by 1. So n minus 2 it becomes n minus 3. Then differentiate sec x. And derivative of sec x is sec x tan x. And then integration sec square x, again tan x. Integration sec square x, this integration is again tan x. So this is my basic differentiation. Then what? This portion remain as it is. Then minus, take n minus 2 outside. Integration. This into this, giving you sec to the power n minus 2x, because here power is n minus 3. And my here power is 1. So n minus 3 plus 1. N minus 3 plus 1, giving you n minus 2. Then tan x into tan x, giving you tan square x. Tan x into tan x, giving you tan square x. Okay. So just basic calculation and derivative. Then what? This remain as it is. N minus 2. Again, write down tan square x as sec square x minus 1. As before, write down tan square theta as sec square theta minus 1. We know this theory. In left hand side, we have in. So this portion remain as it is. Minus. For this, multiply this with this. If we multiply, here my power is n minus 2 and here my power is 2. We know that we can add the power. So my final power becomes sec to the power nx dx. Here my power is n minus 2 and here my power is 2. Minus 2 plus 2 gets cancelled. This becomes sec to the power nx. Then minus minus giving you plus. N minus 2 integration this into 1. Giving you sec to the power n minus 2x dx. Basic calculation. Basic calculation. Just pause the video and write down it. So basic calculation. This into this. Power n minus 2. Here my power is 2. Minus 2 plus 2 gets cancelled. This becomes sec to the power nx. And here this multiply with 1 becomes sec to the power n minus 2x. Okay. Finally, write down this portion as it is. Minus n minus 2 remain as it is. Then sec to the power nx. Then plus, actually, you don't need to write it again. See that. This is my I, this is my in. Obviously, this is my in. This become my in. And see that this is what? Yes, in minus 2. See that this is my in. Here my power is n, but here my power is n minus 2. So last portion that will be in minus 2. See that. Here my power is n, that is in, but here my power is n minus 2. So this will be in minus 2, right? Okay. Then what? Put in here. Take in here. Take in here. And right hand side will remain as it is. Right hand side will remain as it is. Okay. Now, just like the first question, first reduction, take in common. Take in common. Take in common. The right hand side remain as it is. And this is simply n minus 1. Right hand side remain as it is. And finally, both sides divide by n minus 1. And both sides divide by n minus 1, just like the first question. You shall get the form of 1. So there is my another reduction formula. You can easily do this. Our right hand side this. Our right hand side is always this. There is no change in the right hand side. And finally, my in divide by n minus 1 to the right hand side. So my in will be, okay, I'm writing it. Just divide by n minus 1. So my right hand side become this. There is my reduction formula for in. Okay. And try to find this yourself. Integration 0 to pi by 4 sec to the power nx. Try to find it yourself. Just put the limit 0 to pi by 4 here. Just like first two questions. And why this limit is not 0 to pi by 2? Because see that if you put tan pi by 2, we know tan pi by 2 is what? Infinity. Tan pi by 2 is infinity. Recall. That is why you can't take the limit 0 to pi by 2. Because if you put x equal to pi by 2 here, my tan pi by 2 is infinity. That is why this limit is 0 to pi by 2. Okay? So you can easily find this. Our in is this. Just find out this. Integration 0 to pi by 4 sec to the power nx. So just take it as a homework. You can easily solve this. Okay? So this is everything. So my first class on reduction. It is totally an application of pipers. In my second lecture video, I shall solve more questions like this, which is a core application of pipers. So you can watch this. Okay, so you can watch this video, and for any doubt, you can text me. And very soon, I shall make my second video, which is some more application on pipers, and my chapter is reduction. Okay, till then, bye bye.